So I'm Travis Parker. I'm originally from San Diego County, and now I'm at UC Davis, and I'm breeding common bean and working on a project to get virus resistance into some like high value varieties. So this one is called Zuni Gold. I have a few that I'm working with. This is Anasazi. And anyway, it's this, for example, is golden white bean. It's from Native American tribes in the Four Corners region, and I'm working with a company that wants to grow it on hundreds of acres. So we have this virus problem that causes 20 to 30% yield loss probably, based on just like some preliminary estimates. And so if I can make some cross pollinations, then I can select out what we don't want and select for what we're interested in, something that looks like this but has the virus resistance. Ultimately, then we'll get a variety that looks just like this but yields much more. One of the cool things about plant breeding is really anybody can do it. And so for common bean, it's pretty easy to make crosses. So cross pollinations, we just call them crosses. It's easier in some crops than others, so some are really, really difficult. Most are pretty easy. Common bean's pretty easy. You just basically take tweezers, you have to break open one flower, take one little part, and then just transfer it to the other. And then if you get a pod, it's almost always a successful cross-pollination. And then in other species, like in pumpkin or something, anybody can do it. If you just recognize like a male flower, and a female flower, you just do the cross-pollination. Super easy. You can find out how to do that kind of thing on YouTube. And then you just select for whatever you want. So in the first generation, when you make that kind of cross, then almost every single individual is going to be like nearly identical. But then you self-pollinate for a generation, and then just get rid of the stuff you don't want. And it doesn't take any fancy technology at all. Although, look, at UC Davis, I'm using kind of more advanced screens. They're pretty cool. They have like fancy names, but it's really just like baking a cake, and you get like some result. You like run something through what's basically Jello, and see some bands, and just like that helps you remove things more quickly and efficiently.
So you're looking and using genetic markers to
Right.
kind of see what you want and you don't want
Right.
for particular varieties.
Right.
Awesome.
So these are the seeds. So this seed coat, everything that you see is actually just the outer layer, and that is totally dead tissue. The inside, if you've ever broken open like a bean or a pea or a peanut or like a pumpkin seed, it has a kind of a hole on the outside, and then on the inside they're kind of like two little halves that can break open, and those are the cotyledons. That's actually the embryo of the next generation. So the seed coat is actually just maternal tissue. So it's just the mother plant, or like a part of the mother plant, and again, it's totally dead. And so like if I cross pollinate two varieties, if I planted these out, no matter what I cross pollinate as like the other parent, the seeds will always look like this for that first generation. Even though inside there's a hybrid embryo, then you plant out that seed, the seed coat falls off, the embryo grows, you get an adult plant, and then it'll put on, since that's the hybrid plant, it'll put on seeds that have like some totally new, totally bizarre color. So for example, I crossed these golden white beans with a white variety, and you get something that in that next generation that has brown seeds with like little like dark brown speckles all over, which is just something you don't see in either parent at all. Neither parent was brown, neither parent had little speckles, and so anyway, but when you go through the genetics of it, everything makes sense, like when you look at it one gene at a time. So it's very cool.
And how long, in terms of like with breeding with beans, like what's kind of like, how long does it take to stabilize a hybrid? If you were having a very specific mission, like we're looking for this particular thing, you said virus resistance, but how long does it really take often to stabilize a new?
So usually we'd self-pollinate until about the F5, maybe the F6. So your first generation hybrid's F1, and then you just self-pollinate and just, again, select out what you don't want, and then you get F2, F3, F4, and you're doing a lot of selections in those generations. But then the actual amount of variation that you get in each family later on, as you've been narrowing the gene pool, becomes less and less. So by like the F5s, if you take all the seeds from a given individual and plant them out, they look very similar within a family. Whereas like in the F2s earlier, you get a huge range. So again, from the crosses between this and that white seeded bean, we get F2s. The F1s always look brown. The F2s sometimes are brown, sometimes are totally white, sometimes have like the white patches that you see here. Sometimes look like pintos. That's actually really common. Sometimes we get a little bit of pink. So like you really can't predict what they're going to look like, or that some of the plants are super tall, some of them are just super low growing. Just all these other characteristics. But in later generations, it becomes more stabilized. So by the F5 or F6 generation, it's like there isn't a lot of variation within a family. So that's when we think about maybe like increasing the seed and releasing it.
Also wonder, because we talk about population sizes and maintaining the genetic, you know, kind of strength within a population. So like, let's say for example, if you're doing just seed saving and you were going for something, it might be a population of like 20, but if you're doing for breeding and you're trying to breed something out, like what do you, and I know you're working on farm scale, but just for like smaller home scale or like a school project, what might be a good population size to start with, like for the like an F2 generation, if you, I mean, assuming you have that much seeds to start with, yeah.
So in what generation? The F2s or F1 or?
Like F1, like what would you start with? Like what would be a good size so that, because you're whittling down the number of plants that you have to work with as stuff pops out or doesn't pop out, you know?
Yeah, so for bean breeding, all you need is one F1 seed, and that's it. And then so if you made one successful cross-pollination and you plant that out, then you get one plant, or obviously there are more than one, there are multiple seeds in a pod usually, but all you need is one. Plant it out, grow it out, get all your seed, and then we would normally grow out something like 200, 300 F2s, and start the selections there. So we're not interested in the totally white seeded varieties. We want them to be the gold and white color. So in the F2s, you get this nice Mendelian ratio of 3 like colored to 1 kind of albino seed, and you just get rid of the albino solid white seeds and advance those ones that have like some level of color. So yeah, so this summer, for example, I'm going to be growing out 250 F3 families of the cross between this and that solid white bean.
And what got you into seed saving? What kind of inspired you to go this pathway?
It's kind of a long story. I mean, I just think I really have liked gardening for a long time. I've grown all kinds of stuff, and it's kind of like magic. You cross things and you get stuff you would never expect. So anyway, there's also a lot of money in it. So just gonna be totally honest, like people are hiring, you got to kind of consider that. So anyway, it just seems like a pretty good option.